kind of put this up there, right, in case, either for people who are watching the replay of this, or if you weren't here last week, right? So today, basically I'm going to take any questions you have, answer anything about the final exam, and then on this Wednesday, and I see a couple questions coming into the chat, so I'll answer them here in a second. But this Wednesday, which is the 5th, right, there's no class. And then next Monday, which is the 10th, that's when the final exam is, right? And the homework that is due this week, right? So the homework due this week is that chapter 10 topics. And remember, it's optional. If you do it, I'll replace your lowest homework grade. So, right, so if completed, I will replace your lowest homework grade. And really what'll happen is the grades from chapter 10 will transfer over into into Canvas from Alex. And really you'll see after this week, I'll put it in there that it'll just drop your lowest homework grade. So if you have full points for the homework, yeah, you guys are the second ones to ask. You're the second person to ask me that, Cameron. Okay, so if you have hundreds on all the other homeworks, and then you get 100 on the, on that, then maybe I'll throw in a point or two of extra credit, so that you guys, if you decide to do it, and get 100 on the topics. But otherwise, for everybody else who doesn't have hundreds already, what you'll see is your lowest homework grade will get dropped. Okay, and then somebody asked if you can do the review sheet, then you're fine on the final exam. Yep, if you can do the review sheet, you shouldn't have any problems on the final exam. So yeah, maybe I might throw you a bone and give a point or two of extra credit if you have hundreds on all the other homeworks, and then you also do the chapter 10 and get 100. Correct. If you don't do it, it's not going to drop your grade. Yep. And if you don't do it, you're not penalized. Correct. Yeah. So if you don't do it, what'll happen is it'll transfer over as a score of like 0, or depending, you might even have a little bit of credit from Alex. So it'll take whatever score you get on chapter 10 and it'll transfer it into Canvas. But Canvas, I'm going to have Canvas set up to drop your lowest homework grade. So if you've done all the other homeworks and then you don't do chapter 10 will be your lowest and it'll get dropped. So yeah, you're not going to be penalized if you don't do it. So with that being said, what questions you guys have, what things do you want me to go over? Today is pretty much just for you, so whatever stuff you want me to explain or go over or anything like that. So the only thing you should know from chapter 10 on the test is so problems that kind of look like, let me actually share my screen here. Give me 1 second, I'll pull it up. So, okay, and then 2F, yeah. So the review sheet, is actually, that's what I'm pulling up. No problem, I will do 2F, no, not a problem, John. Okay, so you guys should be able to see my screen, right? Like with the review sheet? Okay. And so the way that I get to the review sheet, right, is when you go to the home page and you click on, so just so that we're kind of all sure you guys know how to get to the review sheet, right? When you log into Canvas, if you go to the home page, of our course. If you click down here on test reviews, the test reviews will bring up the page, and it says click here for final exam information. And then here is the review sheet and the problems. So in terms of, so I will not have office hours this Wednesday. I'm actually not going to be here. That's why we're not having class on Wednesday. But I will be available. Like if you have questions, you can send me emails and we can email back and forth. So I have office hours today and tomorrow. But not Wednesday or Thursday of this week. So this week I just have office hours today and tomorrow. So the only thing from chapter 10, if you look at this review sheet, so you can't use the identity sheet on the exam, but the only identities you need to know are the reciprocal, quotient, and the Pythagorean identities. So those are the only ones. So it's not like you have to know the whole entire sheet. These are the only ones I ever make people memorize. Remember, the reciprocal are things we should kind of know because we've been using them. So stuff like the secant of theta is 1 over the cosine of theta, right? Or the cosecant of theta is 1 over the sine of theta. Or the tangent is the sine over the cosine. So those are the reciprocal and quotient identities. And then the Pythagorean identities are just that the one you need to really know is that sine squared plus cosine squared equals 1. So as long as you know those, you're fine. So if you go down here and you look, I gave some examples. So this very last example here, where problem number 9, where it says classify the following equations. So being able to tell me, is this equation a circle? Is this equation a hyperbola? Is it an ellipse? Is it a parabola? That's the only thing you need to be able to do from chapter 10 on the final exam. Does that make sense about the chapter 10 stuff? There is one topic in Alex, in the chapter 10 that has you classify things. Yep. So there's one topic. All the other topics in chapter 10 are about finding like the vertices and the asymptotes and all the other stuff about conics. So other questions, other generic, I know we need 2F, so we'll take number specific questions here in a second, but other generic questions about either the final exam or generic questions about the review sheet. No, there's 11 problems on the final exam, with some of the problems having multiple parts. Other questions? I should also say the vast majority of points of the final exam, like probably about like 2/3 of the final exam, come from questions that are kind of like numbers 1, numbers 3, 4, and 5. So being able to tell me values of trig functions, being able to find inverse trig functions, being able to solve trig equations, those are the 3 most important things. So if you can do those 3 things, then that's most of the final exam. The rest of the other stuff is just kind of a little bit of the final. Other questions? No? Okay, so let me go back to sharing my iPad. I said the ones for the final exam are numbers 1, number 1, number 3, number 4, and number 5. So those ones, so not 2, 3, 4, 5, but 1, 3, 4, 5. Those make up the majority of the exam. No problem. Other questions? Okay, so let me go back to sharing my iPad here. Excuse me. Okay, so 1A, I and J. So okay. So 1A, so asks for, so all of the things in part 1, yes, I can do those as well. All of the things in part 1 are all just values off the unit circle. So part 1 is all just about, do you remember how to find stuff off the unit circle, right? So I'm going to pull up my unit circle here, right? But the idea is like you need to know the unit circle for the test, right? So 1A asks you to find, it gives you theta equals 2 pi over 3. Yeah, so you can write out the unit circle during the test, absolutely. So that is totally fine to do. You get the test and the first thing you want to do is write out the unit circle. That's totally fine. Okay, so the first one gives us theta equals 2 pi over 3. In this problem, I asked you for all of the 6 trig values. If you remember back from test 1, and this is going to be the same on the final, I don't ask for all 6. I might just say the sine of 2 pi over 3 or the cosine of 2 pi over 3, right? I give you just kind of one of them to figure out. I don't ask you for all 6 of them. But if you were finding all 6, I always start with the sine, the cosine, and the tangent. So we're talking about 2 pi over 3, right? So here's 2 pi over 3. And you remember the sine. How do you find the sine value from something on the unit circle? Yeah, so the sine is the y value. So our y value here is root 3 over 2. Whoops. The cosine is which value? X, right? So the cosine would be minus 1/2. And then the tangent, remember, is y over x. So in our case, that would be root 3 over 2 divided by minus 1/2. So if we do for the fraction here, keep, change, flip, you've got root 3 over 2 times negative 2 over 1. So the 2's would cancel. So this would be minus root 3. And then to find so remember, sine is paired with cosecant of theta. Cosine is paired with the secant of theta, and tangent is paired with the cotangent of theta. And to find those, we just flip these over. So 2 over root 3 minus 2 over 1, which is just minus 2. And this would be minus 1 over root 3. Does that make sense for 1A? Okay. Questions on that so far? Okay. Let me add back in my unit circle so we can use it. Let me also down here put a list of things people wanted. So we just did 1A. So let me get down. Okay, so we need 1I, 1J. Somebody asked about 2F. And then 3I, J, 4B, 5J, 7B, and 8C. Okay, just so I have them all written down there. Alrighty. So 1I and 1J. Okay, so 1I gives us, theta equals minus pi over 3. And I'll just write 1J as well, kind of, because they're both similar, right? So 1J is theta equals minus 5 pi over 4. Okay, so remember, negative angles mean you're going clockwise. So usually, right, so all of our angles going this way are positive, but going this way, they would be negative. So while from here to here is pi over 6, from here to here is minus pi over 6. So we're trying to go to minus pi over 3, so minus pi over 3 is going to be here the same as 5 pi over 3, right? So from here to here is going to be minus pi over 3. So we're looking for the sine of theta, the cosine of theta, the tangent of theta, right? So the sine is minus root 3 over 2, which means the cosecant of theta is going to be minus 2 over root 3. The cosine is the x value, so 1/2, which means the secant of theta is going to be 2 over 1, or 2. And the tangent of theta is the y over the x, so minus root 3 over 2 divided by 1/2, or minus root 3 over 2 times 2 over 1. The 2's would cancel, so this would be minus root 3. So the cotangent of theta is going to be minus 1 over root 3. Questions? And then minus 5 pi over 4, it's the same thing, but we're going, so I kind of think about it, so like, here's a pi over 4 spoke, 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 here's a pi over 4 spoke. So if I'm going to count off the pi over 4s, right, I'm going minus 5 pi over 4. So this is minus 1 pi over 4, minus 2 pi over 4, minus 3 pi over 4, minus 4 pi over 4, minus 5 pi over 4. So we're going all the way to here. That's minus 5 pi over 4. And so the sine of theta, the cosine of theta, the tangent of theta, and then the cosecant of theta, the secant of theta, and the cotangent of theta, right? So again, the sine is the y, so root 2 over 2. The cosine is the x, minus root 2 over 2. The tangent is y, root 2 over 2, divided by x, minus root 2 over 2. So that's just going to be negative 1. And then if I flip them over, 2 over root 2, minus 2 over root 2, minus 1. Does that help for that problem? Nope, you don't need to rationalize them. You can leave them just like that. Yeah, so number 1 is really just about the unit circle. Like, can you find values on the unit circle? I took care of all the number 1s. Okay. So let me take with us our stuff. Yeah, I forgot to re-record it as soon as I moved. 5 is so you have the 5 in front of the sine, that's the amplitude. And then you have the pi that's in front of the x, and that affects the period. Right? So remember, the basic sine graph, right? So I usually draw one wave. The basic sine graph starts at 0, and it looks like that. And usually it goes between 1 and minus 1, but here, since our amplitude is 5, it's going to go as high as 5 and as low as minus 5. Are we okay with that? Okay. Then the period, that's how long it takes for one wave, right? So the period is 2 pi over b, and that blue is the b. So this part that affects the period, the number in front of the x, that's equal to b. So in our case, we're going to have 2 pi over pi. And so if you take 2 pi over pi, that ends up being 2. So what that means is out here, one length of the wave goes from 0 to 2, right? So I know it's a little weird because usually our waves go to some multiple of pi, but in this case, just not what happens. And then I generally, remember when we did this, we talked about labeling, like that you want to label these 5 points. So we want to label the axis there. And if you remember, I said, so this is always P at the end here. And then this first one is always 1/4 of P. This is always 1/2 of P. And this is always 3/4 of P. So if you do that in our case, 1/4 of P, so 1/4 times 2 would be 1/2. So this first point here is 1/2. This is 1. And this would turn out to be 3/2. Right, and there's a couple ways you can find them. Like, I personally don't do the 1/4 P, 1/2 P, 3/4 PP. I go, okay, well, this is 2. Half of 2 is 1. Half of 1 is 1/2. And I go, okay, so all of my pieces are a half. So 1/2, 2 halves, 3 halves. That's how I get here. But you could also get it by doing the multiplication out, right? If I did the multiplication out, 1/4 times 2, these would cancel. And that's where I get 1/2. 1/2 times 2, the 2's would cancel and I get 1, right? 3/4 times 2, that 2 cancels, gives me 1, gives me a 2 there to get 3/2. Questions? Does that help, John? I know you were the one who asked that question. No problem. Yeah, so graphing won't be a major part of the test, but there will be like one graphing problem. And it could either be where I ask you to give the graph, or it could be where maybe I draw the graph and I ask you to label some things, and I tell you this here, this is, or it could be, which of the following would be the graph of this, equation. So as long as you can graph it, you should be fine. Questions? Okay, so it takes care of 2f. Let's see if this will just copy all that. Okay, so the next question was 3i. Let me find. Okay, so all of these in 3 are asking us to solve them on the interval from 0 less than or equal to theta less than or equal to 2 pi. Okay, so 3i asks us to solve the cosine of 2 theta equals, negative 1/2. Okay, so remember, when we change the angle, when I did these problems before, I let this stuff inside be equal to something else. So let's say we're going to let the stuff inside here be equal to x. So really we're looking for solving when is the cosine of x equal to minus 1/2. And the thing we have to worry about is x. So if theta is between, so we said theta is between 0 and 2 pi. And so x is the same as 2 theta. So if I multiply all of these by 2, that's a terrible color, I would get 0 less than or equal to 2 theta less than or equal to 4 pi. So remember, 2 theta is x. So x is going to be between 0 and 2 and 4 pi. So that means we're going around the circle 2 times to find our answers. So where on the unit circle, let's just talk about the first time around. Where on the unit circle the first time around would the cosine of x be equal to negative 1/2? Okay, yep. Right here at 2 pi over 3, right? So one answer is 2 pi over 3. Okay, another place is at 4 pi over 3, right? Right here. And then we have to go around a whole time, right? So that's the first time around. I could also go all the way around once and then stop here. So another place would be 2 pi over 3 plus 2 pi. And same thing, I could do 4 pi over 3 plus 2 pi. Are we okay with just those 4 things yet? We're not at our final answer yet. We still have some algebra and a little bit of work to do. But just so far, how I got those 4 places. Okay. So the first thing I'm going to do is I am going to, I want to add these 2 together. And I want to add these 2 together. So remember, 2 pi, I can think of this as 2 pi over 1. And I want to make the denominators the same. So I'm going to multiply the top by 3 and the bottom by 3. Top by 3, bottom by 3. So really I'm going to have 2 pi over 3, 4 pi over 3. We're going to have 2 pi over 3 plus 6 pi over 3. And 4 pi over 3 plus 6 pi over 3. So really I have 2 pi over 3, 4 pi over 3, 8 pi over 3, and 10 pi over 3. Are we okay with that? Okay. That's x. Our final answer needs to be in theta. So remember, x is the same as 2 theta. So what we're saying is that 2 theta is equal to 2 pi over 3, 4 pi over 3, 8 pi over 3, 10 pi over 3. Are we okay with that? Okay, and then I want to get theta by itself, which means I have to divide this by, oops, not theta. I have to divide this by 2, and I have to divide each of these by 2. So theta is going to be, when I divide each of these by 2, it's really 2 pi over 6, 4 pi over 6, 8 pi over 6, 10 pi over 6. Or I could simplify these to pi over 3, 2 pi over 3, 4 pi over 3, or 5 pi over 3. Does that help for that problem? Okay. Questions on that problem? I would take either one. If you left them as 2 pi over 6, that would be okay. Like if you had them over the 6s, I'm okay with that. Other questions before I do the next problem? No. Okay, I'm gonna erase these guys here so I can just copy this. And again. Okay. So the next one, 3j. So again, we're still solving, but this time we want to do the sine of 3 theta equals -1. And again, we're still solving between 0, less than theta, less than or equal to 2 pi. Okay, so just like the last problem, I'm going to let the 3 theta be my x. So really I'm trying to solve the sine of x equals -1. And theta is between 0 and 2 pi, so we want to look at 3 theta, right? So we want 3 times 0 less than or equal to 3 times theta, less than or equal to 3 times 2 pi. So 3 theta is the same as x. So x is going to be between 0 and 6 pi. So basically we're going around our unit circle this time 3 times. So let's just start with the first one. When is the sine of x equal to -1? So 3 pi over 2. So it's only one place here, 3 pi over 2. So that's when I went around the circle the first time. Now I want to go all the way around the circle one time and then stop at 3 pi over 2. So it's going to be 3 pi over 2 plus 2 pi. That's going around the circle once. And then I want to do another one where I go around the circle one time, around the circle 2 times, and now I stop here. So this third one needs to be 3 pi over 2 plus 4 pi, because I went around the circle twice first, and then I stopped. So are we okay with how I got that? 3 pi over 2, 3 pi over 2 plus 2 pi, 3 pi over 2 plus 4 pi. Okay, so now just like we did before, we want to make a common denominator, right? So think of this as over 1, over 1. I'm going to multiply, I want the bottom to be 2, so I'm going to multiply top and bottoms by 2. So really I have x is equal to 3 pi over 2, 3 pi over 2 plus 4 pi over 2. Oh, my rating is slow. Oh, I see that. Okay, let me disconnect and then let me stop sharing and then reshare it. She really does fix it. It's recording here. Okay, so I have 3 pi over 2, 3 pi over 2 plus 4 pi over 2, and now I'm going to have 3 pi over 2 plus 8 pi over 2. Does that all make sense? Okay, so now I'm just going to put these together, right? So x is going to be 3 pi over 2, 7 pi over 2, 11 pi over 2. And then all we have to do now is go back to thetas. So remember, x is the same as 3 theta. So 3 theta is going to be 3 pi over 2, 7 pi over 2, 11 pi over 2. Just like before, I'm going to divide everything by 3 this time. So theta is going to become 3 pi over 6, 7 pi over 6, or 11 pi over 6. And I could simplify that first one, right, and just make it pi over 2. So pi over 2, 7 pi over 6, 11 pi over 6. Does that help for that one? No problem. Okay, so that took care of, that took care of 3. So what do we have? We have 4b, 5j, 7b, and 8c left. Questions before I go to the next page? Okay. So then we're still going to need this unit circle here. Still the problems we have going on. Okay. So let's see. 4b. Okay, so this one asks us to find the general solution. Right, so general solution, sometimes you see it as all solutions. Right, and they don't give you any interval. So we're looking for the tangent of theta equals 1. So when you're asked to find the general solution, the first thing you want to do is you just want to find the answers in terms of the unit circle. So we're looking for where on the unit circle is the tangent of theta equal to 1. So can anybody tell me where on the unit circle? So yeah, so 2 places, at pi over 4 and at 5 pi over 4. Right? So there's 2 places on the unit circle that the tangent is equal to 1. And then the idea is I want to find all the solutions. So the way that I do that is I just add plus 2k pi. Right? Where k is an integer. Right? And this, a mathematical way of saying that is where k is in z. And just like before on the other test, if you forget the k, like where k is in z or where k is an integer part, and you have the pi over 4 plus 2k pi, or the 5 pi over 4 plus 2k pi, that's fine. Now, for the tangent, if you wanted to, you do not have to. This is a totally acceptable answer. How I have it written here, I would take it 100% credit. Only for the tangent or the cotangent, you could actually condense it down to one thing. So if you really wanted to, you could write this as pi over 4 plus k pi, because you can start at pi over 4, and only on the tangent can you move by pi instead of 2 pi. I'm not going to write it that way, because the way I did it here, this works no matter what trig equation you're dealing, or trig function you're dealing with. If you're dealing with a sine or a cosine or a tangent, the same way works. So, does that help on 4b? Yep, that's the final answer. No problem. Okay. So the next one is 5j. And 5j asks for the inverse cosine of minus root 2 over 2. So the things we want to remember when we're dealing with the inverse functions is basically we're looking for here, we're saying for what value, when is the cosine equal to minus root 2 over 2? But the thing you have to remember is that we restricted where the answers could come from when we were dealing with the inverse functions, right? So inverse cosine, your answer could come from the first quadrant or the second quadrant, right? And then we talked about inverse tangent and inverse sine. Inverse sine, first quadrant or the fourth quadrant, and inverse tangent, first quadrant or the fourth quadrant, right? So that's where on the inverse functions, you're only looking in these. So first off, something to notice, you're never giving an answer from the third quadrant in an inverse trig problem. Secondly, so like, I know no one asked for it, but we're going to do 5k as well. So 5k asks for the inverse sine of minus root 2 over 2. Anything that's coming from, that's terrible colors. So this one. Anything that's coming out of this quadrant here, you have to write it. So this is where I put a little asterisk. You have to write as a negative angle. Okay. This is only on the inverse functions. It doesn't mean when you're solving an equation you have to do this. Only if I asked you, what is specifically the problems like this? What is the inverse sine of minus root 2 over 2? What is the inverse cosine of minus root 2 over 2? This fourth quadrant is the only one where you have to make them negative. So, back to the problem at hand. The first one, the inverse cosine of minus root 2 over 2. So we're dealing with inverse cosine. So we're looking in the first quadrant or the second quadrant. And I'm looking for an x value of minus root 2 over 2. Where does that happen? Yeah, 3 pi over 4. So that's the answer here. The answer for 5J is just 3 pi over 4. Oh, so I did that wrong. Then the answer sheet's wrong. I'll make a note of that so I can fix that. Let me find something to write that. So 5J. I'll fix that. Thank you for finding that mistake. 5K, just so we see one, right? So where is so inverse sine is first quadrant, fourth quadrant. So when is the sine, which is the y value, equal to minus root 2 over 2? Yeah, minus pi over 4. So it's technically happening here at the 7 pi over 4, but we have to write it as a minus angle. So it's going to be minus pi over 4. Questions? Yeah, so if it wasn't in the right quadrant, you would need to, so there's not going to be any of those, like the ones on the test are more straightforward. But before, it was like if you had the tangent and the inverse tangent and they canceled each other out and you weren't in the correct quadrant, then you actually had to figure out the inside stuff, get an answer, and then do the inverse function. But there won't be any of those on the test. Other questions? No. Okay, so we have 7b and 8c. Okay, so 7b says convert the following equations to rectangular and determine what the graph of the equation is. Okay, so it gives us r equals 3 cosine theta minus 2 sine theta. Okay, so remember when we were doing these, there were some things we used, some equations we used. We used x was equal to r cosine theta. We used y was equal to r sine theta. And we used that r is equal to x squared plus y squared. And we also used that the tangent of theta was equal to y over x. So those were the 4 equations we used when we were dealing with polar coordinate stuff. So if you look at this, we somehow want to take this equation that was given and we want to turn it into x's and y's. We want to get rid of all the r's and all the thetas. So this equation here, actually, there's a nice little trick that will help us out. If I multiply the whole entire equation by r, right? So I'm going to do r times each piece. So r times r times 3 cosine theta, and r times minus 2 sine theta. Yeah, so this is one of the common tricks. It's a very common trick. It's used a bunch of times. So it probably should have shown up in a homework problem for you. If it didn't, that's why I put it on the review sheet. The idea is, like, I know I need to use it because if this was r cosine theta and r sine theta, then I could just replace them. So it's like, all right, well, let me multiply both of these by r and see if it helps. So if I do that here, I end up with, on the left-hand side, r squared, and then I have 3r cosine theta minus 2r sine theta. Does that make sense, Liana? No problem. And now I know what r squared is, right? R squared is x squared plus y squared. And I know that r cosine theta is x, so this is 3x, minus r sine theta is y, so this would be minus 2y. So in terms of changing the equation, I've changed it. I'm done, right? I know x squared plus y squared equals 3x minus 2y. Done. The second part of the question asks, well, what type of graph is that? Is it a line? Is it a point? What is it? Anybody want to take a guess? Yeah, it's a circle, right? So remember the way to tell if something's a circle, both x and y have to be squared. They are. And the numbers in front of the x squared and the y squared have to be exactly the same. And they are. There's a 1 in front of each of those. So this is a circle. No problem. Questions about that? No? Okay. Then we also asked about 8c. So 8c gave us that w was equal to 3i plus 6j, and v was equal to 6i minus 7j, and c asks us for the length of 2w. So in this one, the first thing I'm going to do is I'm first just going to figure out what 2w is, right? So 2w is going to be 2 times 3i plus 6j, or 6i plus 12j. Does that make sense? Okay, and then the length, so remember, the length of a vector we find by taking the square root of these two numbers, the number in front of the I and the number in front of the j squared. So it's going to be the square root of 6 squared plus 12 squared. So it's going to be the square root of 36 plus 144, right? So square root of 180. Does that make sense? No problem. Any other questions? Can I do 3B? Sure. I can do 3B. Give me 1 second. Will there be a word problem test? No, there will be no word problems on the test. No problem. 3B. Find what 3B is. Okay, so 3B asks us to solve 1 minus the cosine of theta equals 1/2. Okay. And we're solving this in the interval from 0 to 2 pi. So I'm going to add my unit circle here, just so we have it as a reference for me to point stuff out. So you're solving any of these equations. The very first thing you want to do is you want to solve for the trig function, right? So the first thing I'm going to do is I'm going to subtract 1 from both sides to get the part that has the trig function all by itself. So minus cosine theta. 1/2 minus 1 is going to be minus 1/2. And then I'm going to divide both sides by that -1. So really we're looking for when is the cosine of theta equal to positive 1/2. And so now we're going to come over here to the unit circle, and we're looking for when is the cosine equal to positive 1/2. And remember, the cosine is the x value. So I'm looking at all of these pairs of these ordered pairs, and I'm trying to find where is the x value equal to positive 1/2. So where does that happen when theta is equal to what? So not pi over 4. So pi over 4 is, so pi over 4 is root 2 over 2, but pi over 3, yep. So pi over 3, and then again at 5 pi over 3, yep. No, that's okay. I figured you might have just typed it wrong. Does that help, Deanna? Yeah, it's just written a little weird because I wrote the 1 in front instead of like plus 1 at the end. But yeah, it's the same thing. Any other questions? So if it was just like find all the solutions, right? So if the question had been find all the solutions, right, or find the general solution, you would still do the exact same thing. The only difference is here you would write theta equals pi over 3 plus 2k pi, or theta equals 5 pi over 3 plus 2k pi, where k is in z. Does that make sense? No problem. Yeah, I can do 3h. Copy that. Okay, so 3h is root 3 cotangent theta plus 1 equals 0, right? So again, the first thing I'm going to do is get the trig function by itself. So I'm going to subtract 1 from both sides. So I have root 3 cotangent theta equals minus 1. Divide both sides by root 3. So we have the cotangent of theta is equal to minus 1 over root 3. Now, I personally, if I'm given a problem with either a secant or cosecants or cotangents, I think it's easier to flip it and deal with a sine, a cosine, or a tangent. So if the cotangent of theta is equal to minus 1 over root 3, that means the tangent of theta is equal to minus root 3. Okay, so what that means is I need to find on my unit circle, when is the tangent equal to minus square root of 3? And now you might go, well, that's kind of hard to do. The thing is as soon as I know it's a root 3, I either know, as soon as I know the tangent is negative in the second quadrant and it's negative in the fourth quadrant. So I can look at the two places, like two potential places are here, because this has a root 3 in it and this has a root 3 in it. And if you don't know off the top of your head which one it is, what you might want to do is actually do the division. So if I did y root 3 over 2 divided by minus 1/2, that's going to be root 3 over 2 times minus 2 over 1, or minus root 3. And here, if I did the division, you'd have 1/2 divided by minus root 3 over 2. So 1/2 times negative 2 over root 3. So minus 1 over root 3. So I'm looking for when the tangent is equal to minus root 3. So minus square root of 3. So it's going to be this here. So 2 pi over 3. And then it's going to be the equivalent of 2 pi over 3 over here in the fourth quadrant. So here at 5 pi over 3. Does that help, Jolena? No problem. Other questions? Nope. There will not be a problem where you have to find the angle between vectors. So the only type of vector problems you'll get are potentially the ones that are on the review sheet. So maybe you might have to add 2 vectors or subtract 2 vectors or find the length of a vector or find the dot product of a vector. No problem. Other questions? Sure, we can do 2e. Okay, so 2e, y equals 2 times 1/4 x. Okay, oops, I forgot the cosine part, right? 2 cosine of 1/4 x. It's asking you to graph it, right? Heron's formula is not on the test. Nope. So again, right, this 2 is changing my amplitude, and this 1/4, that's my b, and it's going to affect the period. And we're dealing with just a cosine graph, so the cosine wave looks like that, right? And the amplitude is 2, which means it's too high and it's too low. And then that b affects the period. So the period is always 2 pi over b. So in this case, that's going to be 2 pi over 1/4. So that's going to be 2 pi times 4 over 1, or 8 pi. So this point out here is 8 pi. And then I need to find, right, my 5 main points are those guys there, right? Does that make sense so far? Okay, so now I just have to worry about labeling the rest of the axis. Again, you could use my, go in half. So half of 8 pi would be 4 pi. Half of 4 pi would be 2 pi. So I have 2 pi, 4 pi. That makes this 6 pi. Or you could have done that this is 1/4 of p, 1/2 of p, 3/4 of p. Oops. Does that help with that one? Other questions? Yeah, so all these problems in number 2, they're already ready to be graphed. It's just a matter of, figuring out what the different numbers are affecting. So you need to find in this problem the amplitude and the new period. questions? Okay, so if it was a -2, like if you had y equals -2 cosine of 1/4 x, the only difference would be the negative flips the graph over. So that starting graph shape would have looked like this. And so this would have been down here at -2, 2. But then everything else would have stayed the same. So this point here, this still would have been 8 pi. This middle point would have been 4 pi. This point would have been 2 pi. And this still would have been 6 pi. So you still would have had those 5 points and those points on the axis. The tick marks on the axis would still be at the same places. It's just that it would be flipped over. Yeah, you just need to be able to do what I've done here. Okay, so in general, grades for all the classes are not due until the Wednesday after final exam week. So that would be so faculty members for all the classes have until Wednesday, May 19th to do grades. Yep. So grades aren't due till that night. But some people do them faster. Your grades for this class, I would hope, are going to be done way before the 19th. But technically, I have until the 19th, 11:59 p.m. on the 19th to do your final grades. Any other questions? No? Okay. No problem. Thank you. So, if you guys have questions while you're studying, please feel free to email me, right? Feel free to stop by my office hours this afternoon, or tomorrow afternoon. And then, yeah, if you're studying and you have any questions, definitely send me an email and I can help you out. Otherwise, I'll see you all next Monday.